right, so with positive and negatives, you guys have got to start seeing them as what their sign is. So knowing their signs will help you out when you actually go to combine them. Like, what is the sign of the 15? And what is the sign of the 20? And legit, it is like this. If I had negative, it would be like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I have 20 positives. That is legit what I have here. I have 15 negatives and 20 positives. What does every time I combine a negative with a positive, like what does this negative do to this positive? Like if I say, oh, your hair looks beautiful today, but your shirt's really ugly. Like, would that really do much for that person's self-esteem, or did I just kind of cancel out the nice thing that I said? Okay, what happens every time we have a positive and a negative? What do they do to each other? And so I have 15 negatives that are going to cancel out 15 of these positives. So these are going to cancel, and that canceled 15 of these out. But what does that leave me with left over? 5 whats? Does that make sense? Please start think of it like that, and I promise you, you will not struggle with positive and negative integers. I'm going over this because you are the only class that I have ever had who struggled on this concept. Is that true or false? That is big time false. This is a concept that a lot of students struggle with, and that's why I know we need to cover it before we continue. Because what we're going to do today is actually going to combine this skill right here with this skill right here. So if you can't do adding positive and negative numbers and do it perfectly, you're going to struggle today. If you don't know how to plot an ordered pair, you're going to struggle today. If we can do both those skills, which by the way, are skills from the past, today's lesson is super easy. It's very similar to how the rest of math is going to be. We use a lot of the old skills, and we get in trouble when we don't know them. And it's not like kind of know them and get them right half the time. We have to get them right like 90% to 100% of the time. Okay, so that's what we're working on is taking care of that. So what is this right here? What is the sign of the 5? Negative. What is the sign of the 4? The negative does belong to the 4. So I have 1, 2, 3, 4, 5 negatives. 1, 2, 3, 4. When I put these together, are they going to cancel each other out? Only what happens? Positive and what? Only positive and negatives cancel each other out. So negative 5 minus 4 would be? Please put the phones away. I would hate to have to take them. Equals. What kind of 18 is this? What kind of 25 is this? What are those two going to do to each other? So basically, we just find the difference. What's the difference between 18 and 25? How much is it? It is 7. The difference between them is 7. And then how do I know my leftovers are going to be negative? Because the 25 is bigger than 18, so my negatives are going to be the one that's left over. Does everybody understand how to combine positive and negative numbers? We will use this skill big time today. Last, sometimes when I ask you guys to graph, this is what I see. I'm playing. Does that look very nice? Is that how we should be graphing? Listen, take your time. It doesn't take much more time to actually go like this, make the line kind of straight. And then when I'm making my tick marks, what do I want to make sure with my tick marks? What is my goal? To try to make them. Now, am I saying break out the ruler and it better be perfect or I'm going to take off? No. What am I saying? Just try to be a little neat. Some of you guys need to go back and learn about handwriting. It actually does. I know it sounds like I'm being mean, but I can't tell you how many kids have written something like this. Or even worse than that. That's actually pretty decent. Maybe something like this. And what do they see that as? A 3. What did they want it to be? And guess what happens to the entire question now? It's wrong, especially when you get to algebra 2. And you got, the whole problem is this board. It's one question is the entire board. So you got to make sure, start now by taking time, writing it well. All right, this is an ordered pair, correct? What I tell you to think of this as? I said it last week. What did we think of it as? A treasure map. And here is where the pirate starts. And this tells the pirate how far to go right and left. And this tells the pirate how far to go up or down. Positive tells the pirate to go right. Negative tells the pirate to go left. Positive tells him to go up. Negative tells him to go down. So I'm going to go -2. Can someone grab that door? 1, 2, left 2, and then up 1, 2, 3. So this would be my first ordered pair. And then 2, -4, 1, 2, 1, 2, 3, 4. That would be the next ordered pair.
The slope of those lines is 7/4, and the slope of those lines is 7/4, and the point of reflection is 0.5.
Nice, very nice. Want to go even farther? Does that make sense? What we asked you to do? Here, any questions? All right, here we go for today. Today, actually, let's review for a second. On Friday, what did we talk about? What was the last thing we talked about? 3-1. What do we call those? Reflections, yes? What else? What were reflections considered? A rigid motion, yes? What was the thing about a rigid motion? Because there are things that we call like an enlargement or kind of shrinking something or enlarging it. We're going to get to that. But that's not what we're talking about here. What did we say has to happen in a rigid motion? Yeah, so like the angles in the side of this star are going to stay the same. That would be what we would call a rigid motion, right? I don't know if I can flip this thing over. I can do this. That would be a rigid motion, right? Any of those things where it keeps its size and its angles, we would call it a rigid motion. So a new one today. This is 3-2. This is called translations. I like to call them slides. Just like the dance move. We're going to slide to the left. So here we go. -2. We have a worksheet that's going to be on this, and it'll look similar to what I'm doing right now. So this is A, and A is -2, 3. And I want you to translate it by doing x plus 4 and y minus 5. And I want you to give me A prime. This right here is called your translation rule. That is telling you how you are moving it. And what does it tell you are doing to the x? Which, when I say add 4, what does that really do to the x? Moves it which way? Since it's x, is it up or down or left or right? Since it's x, it's left and right. Since it's positive, what way would this move it? So it's going to move it right 4. What is this going to do to it? Okay, so what would my new ordered pair be? Basically, what I'm going to do is take -2 and add 4 to it. And -2 plus 4, what does that get me to? Do you see how we're using the scale that we just talked about? And then we're going to take a 3 and -5. And what are we going to get when we do that? And this would be my new translated point called A what? A prime. This would be considered the what? Free image. Very good. What would this be considered? The image. Does that make sense? Okay. If you have a question, ask it now. Yeah, I mean, -2, 1, 2, 1, 2, 3. Boom. 2, 1, 2, -2. Boom. So this is the image or pre-image, and then it got slid over here to be the image. Yes. So I took this X right here and I added 4 to it. And then I took the 3 and I subtracted 5 from it. So that's where these two things came from. This is the X coordinate. This would be the Y coordinate. And I use this rule to get to my new point. Does that make sense? Do you see how we're combining the two things that we talked about in the bell work? The image is always the second one. Pre-image is, like pre-workout, pre-test. Pre always is kind of before. All right, try this one. I want you to give me A prime, and I want you to graph it. All right. So what does this rule mean? What is that rule telling me to do? I'm going to take the X, correct? And what am I going to do the X? -3, right? So the X for this original is -5. And we're going to -3. And what does that get me for my X coordinate? So X is -8. Translation rule. So they're going to ask you for the translation rule. Or they're going to give you this. This is right here, the translation rule. So then we're going to take -7, add 4. I would call it like sliding. It slides a figure. And when we do that, we get -3. So -3, -8. Now, how many ordered pairs did we do so far? 1, correct? What happens, this is just an idea, what happens when I give you a triangle? So here's a triangle, and I ask you to slide it. I give you a slide rule of x plus 2, y minus 6. Well, can I do it technically? Let's talk about this because I want to make sure we understand this idea. Can I do this for every point on the triangle? This is a point and this is a point, correct? What is this right here? What is a line really made up of from chapter 1? Nope. This is it's a line segment. What is a line segment made up of? How many? So can I do my slide rule to every point? Do I need to do it to every point on the triangle? No, I can't do it to every one. Look, what makes up a line, guys, from chapter 1? So would I do this rule to every single one of these points? I couldn't physically do it. There's an infinite amount of them, correct? But what I can do is I can do the 3 what? What are those called? I should know these coming in. Yeah, the vertices. We can do this to the 3 vertices, and then if I do +2 minus 6, so I go over 2, 1, 2, and then go down 6, and then I go over 2. Don't write this. I'm just talking you through this, and I go down 6, down 6. Come on. And then I go over 2 and down 6. Do you see how I've slid this triangle over 2 and down 6? Does that make sense? So really, we're just going to do this a couple times. So here we go. I'm going to give you the 3 points. So we're going to do a triangle. What if they give you a rectangle? How many points are you going to do? Because you're always going to move the what? So what if I gave you a shape like this? Does it really matter? Can you still translate that? How many points are you going to have to move? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does everybody get that? Good job. All right, here we go. Translate this. A. All right, go ahead and do that one. How many points are you going to have to move? Listen to your instructions. First, I want you to get trans points. So get me the translated points. So give me the translated points. 2, I want you to graph the OG. Halftime show, right? And then I want you to graph the prime. I'm gonna call it the prime. Because when I do my new one, what is this gonna be called? Not A anymore, it's gonna be called what? So I want you to first find A prime and then find, I want you to find A prime, then I want you to find B prime, then I want you to find, then you're going to plot these points on the graph, and on the same one, you're going to plot these points. Does everybody understand the 3 things you're working on? coming by. If you feel like you need some help or me to check it, you can stop me. If you feel like you got it, I am gonna be coming up. No, I mean it is. It's gonna be chapter 3. All right, so here we go. First, I'm going to apply my rule. So if I apply my rule, that means I'm adding 5 to all the x's. I don't care how you do this. Some people I know like to do all the x's first and then do the y's so they stay with the same rule. Some people like to do the x and then the y and get a prime finished. It doesn't matter to me how you do this. So if I add 5 to all the x's, plus 5 right here, what's a negative 3 plus 5 going to yield? Positive 2. What is a negative 1 plus 5 going to yield? Positive 4, right? Make sure we say positive or negative. And then what is a 2 plus a 5 going to get out? Good. And then a 1 minus a minus 6. Sorry, 1 minus 6 is a negative 5 minus 6. Good. Because the same signs are going to add and make more of those things. And then 4 minus 6 is. And then I'm going to take my time. And I am going to graph this nice and neatly. Notice I tried not to give you the numbers too big. I have to go to negative 11. Nothing too bad. So 1, 2, 3, positive 1. What do I call this when I put that dot? What do I need to put beside it? No, that's okay not to have the coordinates. What gives it its name? What point is that? So we're going to label it A. And then I already have the A coordinates labeled over there. Does that make sense? And then B is what? Negative 1, negative 5. And then C was 2. 1, 2, 3, 4. So this is my triangle. Did I do this correct? Double check me. I make errors. All right. Then I'm going to go 2, negative 5. 2, 1, 2, 3, 4, 5. 2. What is this now called? A what? And then B was positive 4. One, 2, 3, 4, and then down to 5, 6, 7, 8, 9, 10, 11. So 4, negative 11. And then finally 7, 1, 2, 3, 4, 5, 6, 7, negative 2. And if I connect these, does everybody see how it's like this whole thing has just been shifted equal distance? Yes or no? Last one real quick. If I told you the original, and I told you, so I told you the pre-image, and now I'm telling you the image. I need the rule now. I need the slide rule. What would my slide rule be? Well, isn't it negative 3 plus something gets me to 6? So negative 3 plus some unknown equals 6. Yes, we are going to practice setting of equations. Then we would add 3, and we'd get x equals 9. So our rule would be x plus 9. Does everybody understand how I figured that out? What would I do for the next one? Tell me what I write. 5 plus y. This time we're going to use y because we're in our y equals what? And then what do I do to get this y by itself? What is that called when I subtract 5 from both sides? No. Nope. Subtraction property of equality. When I do it to one side, I do it to the other. And then y equals, what happens when a -3 and a -5? They add together and I get negative. So it would be y minus 8. And that would be my slide rule.